Alright, we're starting chapter 5. First time we're talking about a new chapter besides chapter 4 this trimester. So, exciting stuff. Chapter 5 here. We're working with exponents and radicals. Radicals are like square roots, cube roots, fourth roots, whatever it is. Right now, we are going to simplify these numbers to the power of a fraction. Okay? Now, these are all to the 1/2. We can write these as radicals. 4 to the 1/2 is really equal to, if we throw this 2 right here, and that 4 underneath the radical to this power, 1, it's really just the square root of 4. We just never put the 2 there, but in a square root, that 2 is always there. What's the square root of 4? 2. Okay, same with this one. This bottom number is going to be our square root, so it's like a square root 2, or square root of 9, which is equal to 3. And this 2, right? 2. Well, there's a 2 there, it's just a square root. What's the square root of 49? 7. Okay, what about to the third power? To the third power. Remember, this 3 is going to go around here where it's a cubed root. So it's really a cubed root 8 to the first power. Or just cubed root 8. Which we talked about earlier when we did cubed roots. The cubed root of 8 is just 2. And now we have something a little different. We have 8 to the 2/3. 8 to the 2/3. Remember, this bottom number comes around, it's like a 3 to 8 with that 2. So it's really the cubed root of 8 to the second power. What's the cubed root of 8? That equals 2. And 2 squared is equal to 4. What? 25 to the 3/2. So again, this 2 is always our root. That 2 is always our root. So it's going to be 2, or the square root, right? We never write the 2 with the square root, of 25 to the third power. What's the square root of 25? 5. To the third power? 5 times 5 is 25, times 5 more is 125. And now we're given that square root, and I want you to write it as a fraction. Okay, so remember, the 4 was always on bottom. The 4 was always on bottom, which makes sense right now, right? Because the 4 is lower than the 3. So we're going to have this 5 just drop down. 5 just drop down. And then we have fractions of 3 and 4. Well, the 4 is lower than the 3, so it's always 3 over 4. That's all I want you to do for this one. Okay, this one, just drop that 7 down. The 3 is lower than the 7. 7/3. That's all I want you to do. That is it. Now we're going to be talking about properties of exponents. So properties. We've done a few of these, right? Like 2 to the first times 2 to the second. When we have exponents, or the same base and different exponents, we can just add these, right? Because this is really just saying, down here, down below, it's really just saying 2 to the first is just 2. 2 to the second is really 2 times 2. Well, this is 2 to the third, right? And if we just added our exponents, 1 and 2, we would get 3, right? So 2 to the third is equal to 2 times 2 is 4, times 2 is 8. Okay, again, 3 to the third, that's really 3 times 3 times 3. 3 squared is 3 times 3. Well, how many do I have? 1, 2, 3, 4, 5. Well, if I just added my exponents, I wouldn't have to do that. 3 to the fifth. 3 times 3 is 9. 9 times 3 is 27. 27 times 3, I'm getting too big. I gotta go 3 to the fifth on my calculator, which is 243. And how about this one? X to the fourth times, or x to the 11th times x to the fourth. Just add our exponents. X to the 15th. Right, now we have something a little different. Now we have 2 squared in parentheses, and that whole parentheses is to the fourth power. So it's really like saying 2 times 2, that's what's in parentheses, to the fourth power. Well, really that's 2 times 2, that's 1, right? 2 times 2, that's 2. 2 times 2, that's 3. 2 times 2, that's 4. Well, how many 2's do I have? 1, 2, 3, 4, 5, 6, 7, 8. 8, 2 to the 8th power. Now up here, in our original problem, where can I get 8? If I multiply those, right? So now we're multiplying. We're going to be multiplying these. 2 to the 8th, you can simplify if you'd like. I have to pull out my phone for a calculator. 3, 4, 5, 6, 7, 8. 256. Okay. I'm going to erase this over here so you can get a little more room. We're just multiplying these exponents here. What is 2 times 1/4? A little refresher, how we multiply fractions. 2 can be written as 2 over 1 times 1/4. We just multiply straight across. What's 2 times 1? It's 2. What's 1 times 4? It's 4. That can be simplified to 1/2, right? So this is 12 to the 1/2. What do we talk about with fractions as exponents? We can bring this around. That's our exponent, so 2 or the square root of 12. Right? And I actually don't even like that 2 there. I just want to write the square root of 12. Oh, this one here. X to the 8th times x to the 10th. What's 8 times 10? X to the 80th. Next, if we have the same base, we can divide 5 to the 3rd divided by 5 to the 4th. Instead of, well actually, let me go up here. When we were just multiplying the same base, right, with exponents, we were adding. Now, same base, we're dividing. What's the opposite of add? Subtract. So really, we're going 3 minus 4. 5 to 3 minus 4. What's 3 minus 4? That's -1. And I'm going to jump ahead of myself here a little bit, but anytime you get a negative exponent, right, -1, that's a fraction, 1 over 5. The 5 goes on bottom. Because it's to the negative first power, it goes on bottom. Oh, this one, 2 to the 12 times 2, or divided by 2 to the 10. 12 minus 10, that's 2. What's 2 squared? That's 4. Oh, this one, x to the 95th over x to the 30th. What's 95 divided by 30, or minus 30? 65. Okay, here we go. We have negative exponents. negative exponents. So 3 to the negative first can really be written as 1 over 3 to the first, or 1 over 3. Same thing goes when it's in the denominator. 1 over 3 to the negative first. Bring that 3 on top. 3 to the 1, or 3. This next one, it says 5 to the negative third divided by 3 to the negative fourth. Well, I don't like negative exponents. It's not right. So we're going to bring 3 to the fourth, right? That exponent now becomes positive when it gets brought to the other side. 5 to the negative third, that's going to be brought to the bottom. And know that negative 3 turns into positive 3. And right now, I'm going to leave it as this. We can't subtract 4 and 3 because these two are not the same base. Right? So we can't subtract. That's as far as I'm going to take it. You could do 3 to the fourth and 5 to the third and figure them both out, but not going to do it. Okay. Which actually is a perfect lead into this next problem, because we have 8 to the fourth divided by 10 to the fourth. They're not the same base, we can't subtract. So, what can we do? We can multiply these exponents. What's 4 times negative 1/4? 4 times negative 1/4, well, that's negative 1. And we can multiply these exponents, right? 10 to the, what's 4 times negative 1/4? Negative 1. Okay, we just talked about it. We have negative exponents, we just switch them. So what's on top goes on bottom. So that is equal to 10 to the first over 8 to the first, or just 10 over 8. Can we simplify that fraction? Yup. 5 over 4. All right, next one. When you get square roots, right? Square roots are the same roots. Like on this next one, it's the square root of 5 times the square root of 20. It's the same root. We can multiply these. What's 5 times 20? It's equal to the square root of 100. What's the square root of 100? 10. Next one. Moving just fine here. We have the same roots, right? Cubed roots. Cubed roots. Well, then we can just take 9 times 3, or 3 times 9. That's the cubed root of 27. Do we know the cubed root of 27? We should. It's 3. Because 3 times 3 times 3 is 27. That is it.